What if I told you almost every SAT math question falls into just 7 patterns? Seriously. Not hundreds, not dozens, just 7. The problem is, most students memorize questions instead of recognizing patterns. So every new problem feels completely different. But 800 scorers don't think like that. They look at a question, recognize the pattern, choose the fastest workflow, and solve. That's exactly what I'm going to teach you today. By the end of this video, you'll have a complete mental framework for attacking almost every SAT math question. Let's get started. Before we dive into each pattern, I want you to completely change how you think about SAT math. Every single question starts the exact same way. You read the question, you recognize the pattern, you choose the best workflow, then you solve. That's it. Not formulas first, not random guessing, pattern first. So what are those patterns? Every SAT math question fits into one of these 7 buckets: function, geometry, equation, modeling, equivalent expressions, graphs, optimization. The amazing part is, once you know which bucket you're in, you already know how to attack the problem. Let's start with pattern number 1. Pattern number 1, function problems. These are questions where the SAT gives you a function, f of x, g of x, h of x, or asks you to evaluate one. Find a value, find where it equals 0, evaluate a composite function. The second I see any of those, I already know I'm in the function pattern. Once I've recognized the pattern, I follow the exact same workflow every time. First, can I graph it? If graphing gives me the answer, I'm done. If not, can I plug values in? Most function questions become much easier once you stop trying to solve everything algebraically. Let me show you exactly what I mean with a real SAT question. The very first thing I notice, it's giving me a function, so immediately, function pattern. Instead of solving this by hand, let's open Desmos. I'm simply going to type y equals 4x plus 28. Now the question asks for the x-intercept and the y-intercept. That's just where the graph crosses each axis. Here's my x-intercept, -7, and here's my y-intercept, 28. The question wants a plus b. That's just -7 plus 28, 21. Answer choice A. Notice what happened. I never started with algebra. I recognized the pattern, graphed the function, found both intercepts, added them together, and solved the problem in under 30 seconds. That's exactly how an 800 scorer thinks. Pattern number 2, geometry. You can recognize these questions almost instantly. A circle, a triangle, a polygon, coordinates, or angle relationships. The biggest mistake students make is trying to calculate before they understand the picture. My workflow is simple. Draw it, label everything, then ask which formula or relationship fits. In geometry, the picture usually gives you the equation, so label everything before you compute. Let's apply that to a real SAT problem. We have points Q and R on a circle with center P. The radius is 9, triangle PQR has a perimeter of 31, and we need the length of QR. So before touching any numbers, I'm drawing the picture. First, draw the circle. Put P in the center, then place Q and R somewhere on the circle. Connect P to Q, connect P to R, and connect Q to R. Now we actually have triangle PQR. Next, label what we know. PQ is a radius, so PQ equals 9. PR is also a radius, so PR also equals 9. The unknown side, QR, becomes X. Now the word perimeter tells us to add all 3 sides. 9 plus 9 plus X equals 31. 18 plus X equals 31. So X equals 13. Answer choice B. Notice the actual math was easy. The key was recognizing that both sides from the center were radii, drawing the shape, labeling every known value, then building the equation from the picture. That's the geometry workflow. Draw, label, match the relationship, solve. This next pattern shows up everywhere on the SAT. Pure equation problems. You can recognize them immediately. Solve for x. Systems of equations. Quadratics. Or expressions that need to be rewritten. There's usually no story, just algebra. And here's my workflow. First, recognize it's an equation problem. Then ask yourself, is it linear, quadratic, or a system? Once you know that, Desmos does the heavy lifting. Here's the biggest shortcut. Plot both sides. Whenever two expressions are equal, their intersection is the solution. And if you're comparing two equivalent expressions like this one, we can actually use regression instead. So here's the flow. Recognize it's an equation, figure out the equation type, put it into Desmos, then read the answer directly. Let's use that on this problem. We want the coefficient b. Instead of expanding everything, we're going to let Desmos find it. Open Desmos, first type x1 equals random, open parenthesis, 10, close parenthesis. That creates 10 random x values. Now type the original expression, open parenthesis, 3x1 minus 23, times, then type a tilde, ax1 squared plus bx1 plus c. That tells Desmos, find the values of a, b, and c that make both expressions identical. Instantly, it gives you a. It gives you b. It gives you c. We only care about b, negative 419. No expanding. No combining like terms. Just recognize the pattern and let Desmos do the work. Pattern number 4 is modeling. These look like long reading questions, but they're really just equations hiding inside paragraphs. You'll recognize them by a few clues. Real-world situations, costs, rates, or growth. They ask you to build an equation. Or they literally say which function best models. The biggest mistake students make? Trying to solve before they've translated. First, build the math. Then, solving is easy. Here's the workflow I use every single time. First, recognize it's a modeling problem. Next, name your variables. What does x represent? What does the function represent? Then, translate the paragraph one sentence at a time. Don't skip sentences. Read one, write the math. Read the next, write the math. Once every sentence becomes math, the answer usually reveals itself. Let me show you. The problem tells us that after 2 hours, the cost is $220. So we have the point, 2,220. Then it says 5 hours costs $400. That's our second point. 5,400. Now, instead of doing all the algebra, open Desmos. Type table. Enter the 2 points. Then type y1 tilde m times 1 plus b. That's the linear regression. Boom. Desmos gives us 60x plus 100. Now compare that equation to the answer choices. The only one that matches is choice A. Here's the speed tip. Write the sentence in math, not the whole paragraph. One sentence, one equation. Next sentence. Add to your equation. Keep translating until there's no English left. Just math. That's how you make modeling questions feel like regular algebra. 4 patterns down, 3 to go. We've handled functions, geometry, equations, and modeling. Now we're hitting one of the ugliest looking question types, equivalent expressions. Pattern number 5, equivalent expression problems. These questions are not asking you to solve for x. They're asking you to rewrite the same value in a different form. Look for phrases like equivalent to, factored form, expanded form, or multiple expressions representing the same thing. Same value is different appearance. The basic workflow is simple. Pick a legal value for x, plug it into the original expression, plug it into the choices. Whichever output matches, wins. But when the question contains unknown parameters like a and b, regression is even faster. Now look at this monster. 5th roots, 8th roots, giant exponents. I am not simplifying all of that by hand. The question tells us the entire expression is equivalent to a times x to the power of b. So a and b are regression parameters. Open Desmos. First, type the original expression exactly as written. 6 times the 5th root of 3 to the 5th times x sub 1 to the 45th, times the 8th root of 2 to the 8th times x sub 1. Then add a tilde, a times x sub 1 to the power of b. But Desmos still needs several x values to compare, so on the next line, create a list. X sub 1 equals open bracket, 1.1, dot dot dot, 100, close bracket. We start above 1 because the problem specifically says x is greater than 1. And boom, Desmos gives us a equals 36. and b equals 9.125. The question asks for a plus b, so type a plus b, 45.125. That's the answer, and that's the speed tip. Don't simplify, substitute. For answer choice questions, plug in a clean value like 2 and match the outputs. For unknown parameters like a and b, create a list and use regression. Same principle. Prove the expressions match without doing unnecessary algebra. And that's the system. Every SAT math question isn't unique. It belongs to a pattern. Your first job is never to solve. Your first job is to recognize. Function, geometry, equation, modeling, equivalent, graph, optimization. Once you know the pattern, you already know the workflow. And once you know the workflow, the question becomes mechanical. No guessing, no panic. Just recognize, execute. That's how you stop treating the SAT like hundreds of random questions and start seeing it as 7 repeatable patterns. Review these patterns, practice the workflows, and pretty soon, every question will feel familiar. I'll see you in the next lesson. If you're serious about maximizing your score, you won't want to miss it. If you enjoyed this video, make sure to subscribe so you don't miss the rest of the series. I'm going to be covering every major topic on the digital SAT, from math foundations all the way to advanced reading strategies. And if you'd like even more help, you can sign up for my free newsletter. You'll also receive 5 free SAT resources to help you study more effectively. If you're looking for personalized support, I also offer private one-on-one tutoring, elite small group classes, and introductory group classes for students at every level. You can find all of that at mus-tutoring.com or reach out to me directly at mus.sat.tutoring@gmail.com. Thank you so much for watching. I genuinely hope this roadmap gave you a clearer direction for your SAT journey. Good luck with your studying, and I'll see you in the next video.